In the name of Allah, the Beneficent, the Merciful. Welcome to the world of biophysics. Due to coronavirus, we had to continue our online class. I'd like to suggest you stay home, stay safe. Let me introduce. I am Mohammad Muqtadir Hossain Bhuiya, lecturer, Department of Physics. Today we are going to discuss about the chapter Physics to Save Life, and today's lesson number 1, Basis of Biophysics, and number 2, Instrument used for diagnosis of diseases. Our next lesson is based on angiography, endoscopy, radiotherapy, ECG, ETT, and isotopes. At the end of this chapter, cadets will be able to explain biophysics, explain the contribution of Jagadish Chandra Bose in biophysics, explain human body, explain the application of ideas and theories of physics in the instrument for diagnosis of diseases in medical science. Key points of this chapter: biophysics, X-ray, ultrasonography, CT scan, MRI. We're going to discuss about all these key points. At first, biophysics. The definition of biophysics is biophysics is a branch of science that uses the method of physics to study biological process. Definition of biophysics. Biophysics is a branch of science that uses the methods of physics to study biological process. We want to know about Jagadish Chandra Bose, and at first he established Bose Science Mandir. He composed response in the living and non-living. He invented crystallograph. We are going to compare between human body and machine. Each organ of human body is interconnected with other organs. Each organs run at its own individual speed. In this sense, the human body is analogous to the most complicated man-made machine. Human body is like an organic machine. It converts chemical energy to mechanical energy, and in human body it transfers chemical energy to mechanical and heat energy by food ingestion and respiration. Instrument used for diagnosis of diseases: X-ray, ultrasonography, CT scan, and MRI. We're going to discuss about all these instruments. At first, X-ray or Roentgen ray. X-ray or Roentgen ray is discovered by Wilhelm Roentgen in 1895. It is electromagnetic radiation, and its wavelength is 10 to the power minus 10 meter. Its penetrating power is more, and it is invisible, produced in the X-ray tube. X-ray tube is one kind of vacuum glass tube, and the total kinetic energy of an electron is T is equal to EV. Here T is for kinetic energy, and E for electron charge, and V for voltage. At first, the X-ray tube, here we have X-ray tube, and that is plus minus, and it is voltage source, it is high voltage source, and it is connected, negative part is connected with a cathode, and from cathode we got electron, and before cathode we have filament is made of tungsten heated by current flow, and from cathode we got electron, and the speed of electron is very high, and it was stuck with anode, and from anode then we got X-ray, and the power of X-ray is high, and its penetrating power is more than any other visible light, and its wavelength is small. This is X-ray tube, and it is also called Police ray tube. The uses of X-ray is we use this X-ray for many purposes. At first, we use X-ray for diagnosis, and these are the uses of a X-ray. Like we'd like to diagnose displaced bones, crack in bone fracture, and any type of disease, face, ulcer, and decay at the root of tooth, the stone present in the gallbladder and kidney, diseases of lung like pneumonia, lung cancer, chest, intestinal obstruction of abdomen, and we use X-ray for treatment purpose, and we have to take some precaution when you use X-ray. The precaution is the patient should be covered with apron made of lead as much as possible. X-ray of abdomen and pelvic region of pregnant women should not be done except in case of emergency. X-ray, we're going to discuss X-ray with with moving picture. At first, the production of X-ray. The production of X-ray, we have a cholestube, this cholestube, and we have tungsten filament, and tungsten filament is made of made of filament is made of tungsten, and we have cathode and we have anode, and the pressure in the cholestube is 10 to the power -6, and we have low tension battery here, and from the, from filament we heated our tungsten, and then cathode we got electron, and electron moves with very high speed, and it got stuck with anode, and the energy absorbed from the electron, moving electron, the anode then emits a ray, and that unknown ray is known as X-ray. In 1885, William Ronson discovered a type of high energy ray that can penetrate through muscles of the body and can create an image of an photographic plate. The nature of this ray was not known then, and hence the ray was named X-ray. Here we have electron and we have target, and we give high potential like 20 kV from battery. Then we get X-ray. Here we have high energy electron and target anode. Now we know that X-ray is an electromagnetic radiation like light, but wavelength is many thousand times smaller than that of the visible light, and thus its energy is much thousand times more than that of ordinary light, and the wavelength is very small. Our next topic is ultrasonography. This is the process of ultrasonography. Here we are going to discuss this diagram. At first, we use transducer, and by transducer we have produce ultrasound or high energy, high frequency sound producer, like 1 to 10 megahertz. Then the sound and sound wave go through the body, and it produces echo. And from this echo, we produce uh, a signal, and by radiographer and computer panel we got an image of this object in the monitor. And the uses of ultrasonography is obstetric and gynecology. The fetal size, maturity, and normal and abnormal position of fetus can be known. Uterine tumor and pelvic masses can be identified. Gallbladder stone defect in the heart, like echocardiography. An advantage of ultrasonography is fast, relatively safe, reliable technique in the field of gynecology, and we have to take some precaution when you use ultrasonography, like the transducer should always be kept in movement so that it doesn't become static in a position. We are going to discuss ultrasonography with moving picture. Observe this diagram. At first, the basis of ultrasound. By ultrasound, we have transducer, and with the transducer, we produce ultrasound waves, and it produce uh, from the fetus we got echo, and echo also received by the transducer, and we process this echo wave and process ultrasound wave. We produce an image of the internal organ and muscle of the body are captured by using ultrasonography. To do this, a very high frequency sound is produced and its echo is used. As the frequency of the sound lies between 1 to 10 megahertz, this is called ultrasonography. We generally got 2D, and recently we invented 3D ultrasonography as shown. Here we have an element that generate signal in reverse, and we have EQ waves. Then the image formation of by ultrasound. By using ultrasound, we can manage image. The images of internal organ and muscle of the body are captured using ultrasound. To do this, a very high energy sound frequency is produced and its echo is used. And as the frequency of the sound is between 1 to 10 megahertz, this is called ultrasound. By using this ultrasound, we can form an image. Here, observe this moving picture, then you'll get information. In an ultrasound machine, a crystal called transducer is stimulated with a critical position, and the electron energy is produced a high frequency ultrasound wave. In the ultrasonic machine, this wave is transformed into a narrow beam. The transducer is touched upon that the part of the body, and that produce image. The beam center, the sound beam interaction. By using the transducer is touched upon the part of the body, needs to be imaged. The beam enters the body, and thus the patient doesn't feel any pain or discomfort. Sound wave weaken over distances, and the beam enters the body, thus the patient doesn't get feel any pain or discomfort. At first, the sound wave absorbed, and then we got echo from this part, and we have far field TGC. Then the part is reflection. See the reflection from this organ. Sound wave are reflected and absorbed by structures, and heart reflection from heart like bone. We got reflection. Ultrasound wave almost completely reflected by solid structure or where. To avoid this, we use gel in the upper part of the body. Then we have many organs that acts as a scatterer. There's the irregular surface, and there are many types of scatterer in our body. Then we have acoustic coupling. Ultrasound is reflected, and we want to uh, avoid this type of scatterer. Then we use gel, and by using gel we can avoid the scatterer. Gel ensures proper contact between the surface and the transducer, and here we use the frequency like 1 to 10 megahertz, and that's beyond our capability to hear. Normally we hear between 20 to 20 kilohertz. But to get an image by ultrasonography, we use a sound like frequency 1 to 10 megahertz. That's why the sound is called ultrasound, and by using this we got the image. And we normally hear from 16 to 20 kHz. 20 kHz plus sound is called ultrasound. That is heard by well and bad. In transducer, we produce sound 1 to 10 megahertz. The vibration of the transducer produce these types of frequency, and by this we generally got a 2D image. And recently we invented 3D ultrasonographic image, and when the beam incident on a muscle or on an interface of the blood of different densities, the part of the beam is reflected back to the transducer as an echo. Now we are going to review. Review one is introduction to ultrasound. Ultrasound images are formed by listening to reflected echoes, generally by sound beam, and ultrasound get attended to tissue. Signal get weaker in deeper structure, resulting in darker image. Then high frequency is equal to high resolution. Lower frequency is uh, used for deeper image, and the absorption may prevent imaging behind solid structure. High reflection may prevent imaging behind solid structure also. Now we're going to discuss about CT scan. CT scan is nothing but computed tomography scan, and we use CT scan for the detection of cancer in liver, lung, and pancreas, tumor size and position. Any type of bleeding inside the brain, swelling of artery, and problem of blood circulation can be detected by CT scan. And we have to take some precaution for pregnant women. If dye is used in CT scan test, there is a possibility of allergic reaction. CT scan is previously known as CAT scan, and CAT scan have the abbreviation of computed axial tomography. Previously, it is known as CAT scan, but at present we use the term CT scan. CT scan mean computed tomography, and CAT scan mean computed axial tomography. And here we're going to discuss about CT scan. In CT scan, we use a bed and radiographer is necessary to operate this machine, and we use X-ray to get CT scan. Here we have a arc, circular arc. In circular arc, we normally produce X-ray and it transmits through the object uh, that we use to get an image. Then we have the entry in where the X-ray produced, and here we have circular arc, and we produce X-ray from the blow part, and we have photographic plate in the opposite side. Then we get image of this object. Here observe this circular arc, and we generally throw X-ray from the circular arc. Here from different angle we want to take picture for 3D object. Here tomography means to create an image of a slide of three-dimensional object in medical science, X-ray is used in this machine. In an ordinary X-ray, a two-dimensional image of a three-dimensional internal organ is taken once from different angle. At first, we take an image at 0 degree angle, and then from 90 degree angle, and then we take an image from 45 degree angle. Here, a two-dimensional image of three-dimensional internal organ is taken in a CT scan machine. An X-ray tube rotates around the patient's body in circular way, emitting X-ray. From the other side, a detector records the image to make the image clear. Often, a special contrast material is injected into the patient's body, and then we capture the image from different angle like 0 degree, 90 degree, and 40 degree, 45 degree. And after getting X-ray image of the surrounding, they are analyzed by a computer and then coordinated, and thus the internal structure of a complete slice is obtained. After recording the image of a slice, the CT scan machine moves the patient a bit forward and again records another X-ray image circularly. Analyzing them create a complete image of the internal structure of a second slice. In this way, moving the patient forward gradually, the image of many slice of an organ of his body is recorded. As we get a complete loaf of bread, by arranging the many slices one after another, we can form a three-dimensional image of the internal organ of the body by accumulating the images of many slices. By using computer, we get a complete image. We can form a three-dimensional image of the internal organ of the body by accumulating these images of many slices of that organ. You can tell that the CT scan machine is costly, complex, and large machine by knowing about its working procedure, but this machine can build a flawless three-dimensional image of an internal organ without going the inside of the body. It is essential machine for modern medical science, and we got image like that by actually we want to get a three-dimensional image, but at first by using X-ray we got two-dimensional image, and all these two-dimensional image accumulated by computer tomography, then we got three-dimensional image. Our next topic is about MRI. MRI is nothing but the magnetic resonance imaging. It works depending on the physical and chemical principle of nuclear magnetic resonance, that is named as NMR. This is a painless and safe diagnosis method. Uses of MRI is twisting of ankles and back pain, brain and spinal cord. This is the instrument of MRI. By using a moving picture, we're going to discuss about MRI, that is magnetic resonance imaging. We have different parts like radio waves, gradient, and by using these, all these, we uh, got an image by using computer. Almost 70% of human body is water, which means water is present in almost all organs of the body. Each molecule of water contains hydrogen, and the nucleus of hydrogen is a proton. When a strong magnetic field is applied, when a strong magnetic field is applied, the protons is aligned in the direction of magnetic field. Here, MRI stands for magnetic resonance imaging. When a strong magnetic field is applied, the protons is aligned in the direction of magnetic field. Then, if an electromagnetic wave of definite frequency is sent, then these photons receive energy from wave and change their direction. This process is called nuclear magnetic resonance, that is MRI, NMR. Based on this remarkable event of physics, MRI has been made. The MRI machine looks like the CT scan machine, but its working process is completely different. In CT scan machine, we use X-ray. X-ray stand to record the image, but in MRI machine, patient is kept very in a very strong magnetic field, and a radio frequency electromagnetic wave is applied to his body. Here, when strong magnetic field is applied to the uh, to the body, protons is aligned to the direction, and for external magnetic fields, it produces a resonance. It produces resonance. Then, if an electromagnetic wave of a definite frequency is sent, then these protons receive energy from that wave and change their direction. This process is called nuclear magnetic resonance. Based on this remarkable event of physics, magnetic resonance imaging, in brief of MRI, has been made. Here we produce an image by nuclear magnetic resonance, and we got different picture of the. Based on our today's lesson, we are going to discuss about knowledge-based question. At first, the question is, what are X-rays? X-rays are a type of radiation called electromagnetic waves. X-ray imaging creates picture of the inside of your body. The images show the parts of your body in different shade of black and white. The most familiar use of X-rays is checking for fractures, that is broken bones, but X-rays are also used in other ways. Next question is, what is CT scan? A computerized tomography scan combines a series of X-ray images taken from different angles around your body and uses computer processing to create cross-sectional images of the bone, blood vessels, and soft tissues inside your body. CT scan images provide more detailed information than plain X-ray do. Our next question is, what is an MRI scan used to diagnose? MRI uses a large magnet and brainwave to locate the organ and structures inside your body. MRI is very useful for examining the brain and spinal cord. Next question is, what is biophysics and examples? The definition of biophysics is the science dealing with how physics applied to the process of biology. An example of biophysics is explaining how birds fly. Our next question is, what is biophysics? Previously, we have discussed about the definition of biophysics. Biophysics is a branch of science that uses the method of physics to study biological processes. Physics uses mathematical laws to explain the nature of world, and it can be applied to biological organism and system to gain insight into their workings. Comprehension based questions. At first, number one, why is biophysics important right now? Biophysics is pretty damn important to the molecular biosciences such as biochemistry and genetics. Due to structural biology, biophysics is why we know that DNA is a double helix, which lead to understanding how DNA stores genetic information. Biophysicists do have a claim to the rise of molecular biology. Next question is, how does an X-ray work? Today's X-ray machine produces a stream of electromagnetic radiation that interact with an anode in an X-ray tube. When X-ray come into contact with our body tissues, they produce an image on a metal film. Soft tissues such as skin and organs cannot absorb the high energy rays and the beam passes through them. Next question is, how bad are X-rays? While X-rays are linked to a slightly increased risk of cancer, there is an extremely low risk of short-term side effect. Exposure to high radiation level can have a range of effects such as vomiting, bleeding, fainting, hair loss, and the loss of skin and hair. Next question is, how many X-rays are safe in a month? Here the answer is there is equal to 10,000 chest X-rays or up to 25 chest CT scan. Next question is, can an X-ray show lung cancer? Chest X-ray can detect cancer, infection, or air collecting in the space around the lung. They can also show chronic lung condition such as emphysema or cystic fibrosis, as well as complications related to these conditions, heart-related lung problems. Our next question is, does bone cancer show up on X-ray? Most bone cancers show up on X-rays of the bone. The bone of the site of the cancer may look ragged instead of solid. The radiologist can often tell if a tumor is malignant by the way it appears on the X-ray, but only a biopsy can tell for sure. Next question is, what X-ray scan can do? A computerized tomography scan combines a series of X-ray imaging taken from different angles around your body and uses computer processing to create cross-sectional images of the bone, blood vessels, and soft tissues inside your body. CT scan images provide more detailed information than plain X-rays do. Our next question is, what can X-ray scan detect? CT scan can detect bone and joint problems like complex bone fractures and tumors. If you have a condition like cancer, heart disease, or liver masses, CT scan can spot it or help doctors to see any changes. They show internal injuries and bleeding, such as those caused by a car accident. Homework for you: observe the diagram and answer the following questions. Number A, what is CT scan? Write down two uses of X-ray. And next question is, discuss the structure and functions of the instrument that represented by the figure above. Next question is, instrument represents in the above figure has tremendous contribution to diagnose and treatment purpose. I hope if you follow my lecture, then you will be able to explain all these questions. And here is a creative question for you. Read this question and solve this question. If you find any difficulties, then you can ask any types of question in your class time. Thank you all for joining me. Hope that all of you are fine. Stay home, stay safe. Allah Hafiz. That's all for today. Once again, stay home, stay safe. Make the best use of your time. Allah Hafiz.